Imagine for a second, you're standing right on the edge of a bridge. You've got a bungee cord strapped to your ankles, and your toes are just sort of hanging over the void.
Yeah, that pure adrenaline hit.
Exactly. You've got that mix of just pure, unadulterated excitement coursing through your veins. But then underneath all that adrenaline, your rational brain is sending up warning flares, giving you this very real, primal sense of absolute terror.
Because, you are willfully stepping into a scenario that your conscious mind knows is incredibly dangerous. It is the ultimate conflict between your thrill-seeking instincts and, your basic biological self-preservation.
Right. And today we're taking that exact emotional cocktail, that precarious balance of pure nostalgia and absolute visceral terror, and applying it to the digital asphalt.
Welcome to our deep dive, specifically for our GT7 car introduction series.
We are looking at a massive stack of sources today. We really are. We have dug through translated Japanese automotive archives from the early 90s, some incredibly candid interviews with legendary race car drivers, and intricate physics patch notes from the developers of Gran Turismo 7.
The amount of data we combed through just to understand the sheer violence of this vehicle is honestly staggering.
So our mission today is to synthesize all of that into one clear answer. We want to figure out why combining the 1992 Nissan R92CP with the newly revamped high-speed ring is like the ultimate digital test of courage for anyone holding a controller.
It really is the ultimate test.
Now, I'm approaching this as someone who just loves firing at the game, buying a fast car, and just mashing the throttle to see the world blur, But looking at the source material for this specific matchup, I know I'm entirely out of my depth. Tell me what we're actually dealing with here.
Well, we are dealing with a machine that borders on the mythical. Let's lay down the raw numbers, because to understand the legend, you really have to understand the physics first.
Okay, lay it on me.
This is a 1992 Group C racing machine. Sitting right in the middle of its chassis is an absolute masterpiece. A 3.5-liter V8 twin-turbo engine, specifically designated as the VRH35Z.
Catchy game.
Very catchy. The car weighs a mere 900 kilograms, and the official spec sheet boasts a nominal 800 horsepower. It utilizes an MR layout, and it has this insane power-to-weight ratio of roughly 1.1 kilograms per metric horsepower.
Okay, wait, let me jump in here and process these numbers, because if I'm sitting on my couch trying to tame this thing, I need to know what that actually translates to. You said it has a power-to-weight ratio of 1.
Yeah, 1.1.
If I think about a standard commuter car, that ratio is probably closer to, 10 or 12 kilograms of weight for every single horsepower?
Right, easily.
So this Nissan has almost one entire horsepower for every single kilogram of weight. That sounds less like a race car and more like a horizontal rocket ship.
It is borderline aeronautical. When a vehicle approaches a 1-to-1 ratio of weight to power like that, all your safety margins just evaporate. The body is this featherweight 900-kilogram carbon composite shell, meaning the power delivery is incredibly fine.
I can imagine.
Yeah, automotive engineers refer to this as a peaky power layer.
Let me guess, peaky means it doesn't build speed smoothly, like a modern electric vehicle? I imagine it's more like a dam braking.
Oh, that is exactly what it's like.
Like you press the throttle, the exhaust gases start spinning those massive twin turbos, you feel a moment of hesitation, and then suddenly the pressure crosses a threshold and all that power hits the rear wheels in the exact same millisecond.
That is a perfect way to visualize turbo lag from that era. It requires intense anticipation from the driver. And you mentioned the MR layout earlier. That stands for mid-engine, rear drive.
Right. And I know MR layouts are usually praised for balance because the engine isn't hanging over the front axle. But if that massive 3.5-liter V8 block is sitting right behind my shoulder blades, doesn't that effectively turn the car into a giant pendulum?
It absolutely does.
Like all the heavy mass is concentrated in the middle, so if I mess up a corner and upset the balance, won't it just swing around and snap me into a wall?
That is the exact mechanical trade-off here. It's a concept called the polar moment of inertia. Because the heaviest part of the car is centrally located, the vehicle can pivot and change direction with just mind-bending agility.
It turns on a dime.
Exactly. It reacts instantly to steering input. However, that agility is a double-edged sword. If you lose traction, that central mass wants to keep moving in whatever direction it was already going.
Which means you spin.
Yeah, it will swing the rear end around faster than human reflexes can catch it, so it is incredibly agile, but just completely unforgiving of mistakes.
Man, so if you want to survive driving this car, you first need to understand the beast you are dealing with. My question is, how did a machine this unhinged even come to exist? Car manufacturers don't usually build things this extreme without a very specific reason.
The historical context is fascinating. This car represents the absolute zenith, the final evolution of Nissan's Group C turbo era. They engineered it specifically for the 1992 Japan Sports Prototype Championship, known as the JSPC. During this era, a lot of racing teams would outsource their chassis to European specialty builders like Porsche or Lola and just supply the engine. But Nissan took a completely different approach.
What did they do?
The R92CP was a pure, unadulterated Japanese build. Both the chassis and the engine were developed entirely in-house.
Why does that matter so much then? I assume keeping it all under one roof allowed for a level of synergy they couldn't get by bolting their engine into someone else's frame.
That is the exact reason. When you build the chassis and the engine together, you can perfectly tune the rigidity of the carbon tub to handle the specific torque curve of that V8. And the team behind this was a powerhouse of Japanese engineering.
Who was on the team?
The engine itself was crafted by Yoshimasa Hayashi, who is an absolute master of internal combustion. And the team director managing the entire project was Kazutoshi Mizuno.
Wait, Kazutoshi Mizuno? That name definitely rings a bell for anyone following modern sports cars. Isn't he the legendary engineer who went on to create the R35 Nissan GTR?
The very same. The man known as Mr. GTR cut his teeth directing the R92CP program. He brought a philosophy of absolute mechanical cohesion, and the motorsport results were staggering.
Yeah, I saw that in the sources.
The R92CP's dominance is almost unparalleled in racing history.
The sources mentioned a winning streak. Just how dominant was this car on the track?
It was entered into all 6 races of the 1992 JSPC season, and it won every single one of them, a perfect 6 for 6. Driven by aces like Kazuyoshi Hoshino and Toshio Suzuki, specifically in the famous Kawasaki liveried #1 car. It claimed both the drivers and manufacturer's titles, but Nissan wasn't finished. They brought the car out one last time for the 1993 Suzuka 1,000-kilometer endurance race.
Yes, they won that one too.
It took first place, securing a perfect 7 for 7 across its racing career. It retired undefeated.
Okay, that actually brings up an interesting contradiction for me. If a car is engineered with that much synergy, if it is so perfect that it never lost a single race, why do the sources, specifically the driver interviews, talk about how terrifying it was?
It's a very fair question.
Right. Shouldn't a winning car be easy to handle? A perfectly engineered, undefeated race car should theoretically be smooth and compliant, right?
You'd naturally assume a winning car is an obedient car. But here's where the reality of Group C racing completely shatters our modern expectations. Earlier, we established the official specification for the BRH35Z engine was 800 horsepower.
Right, which is already an insane number for a 900-kilogram chassis.
It is. But that 800 horsepower figure was strictly for race pace because the rules mandated strict fuel consumption limits. Had to make the fuel last.
Makes sense.
But during qualifying sessions, those fuel efficiency rules were just thrown out the window. The mechanics would dive into the engine bay, essentially pin the wastegates on the twin-turbos shut to force maximum compressed air into the cylinders and just dump unrestricted amounts of high-octane race fuel into the mix.
Wait, so they were essentially treating a $1 million piece of engineering as a disposable item just to secure pole position for the starting grid.
Yes, exactly. They were deliberately pushing the metal to its absolute breaking point. The rumors from the paddock, which have essentially become legend now, suggest that during those qualifying laps, the engine produced nearly 1,500 horsepower.
1,500 horsepower. Are you kidding me? In a car that weighs less than a modern compact hatchback, how does a driver even put that power down to the pavement?
Barely. I mean, on the massive main straight at Fuji Speedway, the R92CP reportedly topped 400 kilometers per hour. That is nearly 250 miles per hour.
That's just absurd.
The sheer violence of the acceleration would instantly overwhelm the mechanical grip of the rear racing slicks. The legendary drivers steering this machine, men like Hoshino and Masahiro Hasemi, who are considered absolute titans of Japanese motorsport, they publicly admitted to being terrified of their own creation.
You know, when professional racing drivers, guys who literally get paid to ignore fear, admit a car scares them, you know you are dealing with an anomaly.
Absolutely. Hoshino is on record stating that simply pushing the accelerator pedal fully to the floor required a, quote, readiness to sacrifice one's life.
A readiness to sacrifice your life.
Yeah, the physical and mental barrier of unleashing 1,500 horsepower in a featherweight carbon tub was something they had to overcome every single lap. And Gran Turismo 7 really respects that heritage.
How so?
Well, in the game, this isn't something you just buy at the local dealership. It's classified as a legend car, requiring players to spend between 2 and 3 million credits in the legendary dealership just for the privilege of experiencing that fear.
Which leads us perfectly into the other half of this equation. You have an engine that acts like a bursting dam, violently dumping power to the rear wheels. You cannot drive a vehicle like this around a tight, claustrophobic city circuit. To even shift into third or fourth gear, you need an endless stretch of tarmac. And that is exactly why the developers revamped the high-speed ring.
Yes, the high-speed ring is the perfect digital canvas for this machine. It holds a very special place in the hearts of sim racing fans.
It really does. Looking through the game's history, the high-speed ring has been around since the very first Gran Turismo dropped back in 1997.
A total classic.
It's a fictional circuit, and it disappeared for a few generations. It wasn't featured in GT3 or GT Sport, but the developers beautifully revamped it for GT7. Because of its relatively short 4.345 kilometer length and its sweeping layout, players have universally adopted it as the ultimate test track.
Oh, for sure.
If you buy a new car and want to see what it's truly capable of, you take it to the high-speed ring.
And the game structurally encourages that too. It's the designated venue for major in-game events like the GT Cup GR4, the American Club and Cup 700, and the Japanese FF Challenge 450. But if we analyze the track's architecture, it is fundamentally designed to build speed.
Break it down for us.
You launch into a massive, heavily banked turn one that you can navigate at terrifying velocities. You roar across this beautifully rendered suspension bridge, which actually creates a strobe effect on your screen as the pillars flash by. It really heightens the sensation of speed.
I love that section.
And then you hit the centerpiece, a 1,060-meter long straightaway.
Over a kilometer of perfectly flat asphalt where you can just pin the throttle to the floor and watch the speedometer climb into the stratosphere.
But every massive straightaway must eventually end. And that brings us to the danger zone, turn two.
Turn two.
When the developers brought the high-speed ring into GT7, they didn't just update the graphics. They actively changed the geometry of the track. They moved the pit lane entrance near the exit of the final corner to reflect modern motorsport safety standards. But more importantly, they radically altered turn two.
I noticed that in the patch notes, the radius of turn 2 is made about half as tight as it was in the classic PlayStation 1 and 2 eras.
Exactly.
Wait, why is turn 2 suddenly a death trap in GT7? Why would they do that? I can only assume they saw modern sim racers driving aerodynamic cars flat out through the old wider corner, which completely removed the skill gap.
Right, it was too easy.
So by tightening the corner, they force a brutal contextual braking zone. What do those terms mean for me holding the controller?
That is an incredibly astute observation. By constricting that radius, Turn 2 became a graveyard for overconfident drivers. It introduces severe technical demands, specifically concerning your entry speed, the management of understeer, and hitting your clipping point.
Okay, let's translate those mechanics for the listener. If I'm coming down that 1,060 meter straight at 400 kilometers per hour, my entry speed, the velocity I'm carrying the moment I attempt to turn the steering wheel, is completely off the charts.
Right, it's massive.
So if I misjudge my braking marker by even a fraction of a second, the physics engine takes over. I can turn the DualSense controller all I want, the front tires might angle into the corner, but the forward momentum is just too great. The tires break friction, and I slide helplessly straight into the outside barrier. That's understeer.
You've perfectly described the physics of understeer. The car physically cannot perform the steering input you are demanding. And because you are sliding outward, you entirely miss your clipping point.
And the clipping point is the apex.
Yeah, the innermost apex of the corner where your tires should ideally kiss the curbing to maintain the fastest, tightest racing line.
Which brings us to the ultimate question of this deep dive. What happens when you combine these two extremes? What is the physical and digital reality of taking the 900 kilogram R92CP with its rumored 1,500 horsepower and unleashing it on that kilometer-long straight before throwing it into the newly tightened Turn 2?
It creates absolute maximum synergy. It is a complete sensory overload. Imagine the lap you exit the final corner and surge onto the banking of turn 1. You are absolutely flat out.
Right.
At speeds approaching 400 kilometers per hour, the aerodynamics of the Group C chassis come into play. It isn't just about the massive rear wing. The underbody of the car features Venturi tunnels that channel air to create a low-pressure vacuum beneath the vehicle.
Ground effect.
Exactly. This ground effect generates a mind-bending 3.5 tons of downforce.
3.5 tons, so the ambient air is literally crushing the vehicle into the pavement. That flat, iconic silhouette is physically sucked onto the track, artificially increasing its weight to provide massive grip.
Precisely. You fly off the banking, crossing the suspension bridge, and the acceleration is so relentless that the digital scenery physically blurs on your television.
It's intense.
And your audio is completely dominated by the deafening guttural roar of the VRH35Z spooling its twin turbos. It is pure, sustained violence.
I can feel my own pulse rising just thinking about the force feedback vibrating through the controller. But downforce only helps you when air is rushing over the car. What happens when you reach the end of that straightaway and you finally have to hit the brakes for turn 2?
That is the moment of truth. You are traveling at aeronautical speeds and you have to engage in threshold braking using the car's carbon-ventilated disc brakes. Unlike modern GT3 cars in the game, you don't have anti-lock braking systems to save you.
No ABS at all.
None. And this is where weight transfer becomes your biggest enemy, leading directly to rear traction loss and snap oversteer.
Let's break down that physics sequence. Explain weight transfer and rear traction loss here. Why is the car trying to spin me out just because I pressed the brakes?
It's the seatbelt effect, right? Yes, great analogy.
When you slam the brakes in a normal road car, your body gets thrown forward against the seatbelt because your momentum wants to keep moving. In the game, when I hit the brakes at nearly 400 kilometers per hour, all 900 kilograms of the car's weight violently pitches forward onto the front tires.
Exactly.
The front tires get crushed under the load, but the rear of the car suddenly lifts.
Right. The mechanical weight transfer completely unloads the rear suspension. The rear racing slicks are virtually lifting off the asphalt, severely reducing their contact patch. They suddenly become light and lose their grip on the road. That is rear traction loss.
And because this is an MR layout, that heavy engine behind you acts like a pendulum.
Yes, that central mass.
The rear tires lose grip, but you have this massive block of metal wanting to keep traveling at 400 kilometers per hour. If my steering wheel isn't perfectly straight, that engine swings the rear end around, overtaking the front tires, and sends you spinning backwards into the wall. That's oversteer.
It is a violent terminal oversteer. You have to be incredibly delicate with the pedals to survive. You must squeeze the brake trigger smoothly, managing the friction of the carbon discs, carefully bleeding off speed without upsetting the delicate balance of that central pendulum.
It demands absolute perfection.
It really does. If you brake too late, you understeer into the wall. If you brake too aggressively and upset the balance, you oversteer and spin backward into the wall.
So, to summarize the experience for the listener, it is pure digital catharsis. You get to unleash the raw, unhinged turbo power of a bygone racing era on a track specifically designed to let it stretch its legs, provided you have the exact pedal control to survive turn 2.
Exactly.
It's an experience modern racing cars simply can't replicate. Modern cars are engineered to save you from your own mistakes. The R92CP demands that you save yourself.
That distinction is exactly why this specific car and track combination remains so legendary. Modern engineering has systematically insulated drivers from the raw mechanical violence of the road.
It's true.
And it leaves you with a final thought to mull over. If wrestling the digital recreation of this car from the comfort of your living room demands absolute concentration, white knuckles, and induces genuine adrenaline,
Right.
imagine what it was truly like for Hoshino and Suzuki in 1992. Picture being strapped into a vibrating, deafening carbon tub in the pitch black of a grueling endurance race.
Low restart button.
None. Knowing that pressing your right foot to the floor in a 1,500 horsepower, 900 kilogram machine literally meant putting your life on the line.
Wow.
Next time you hit the high-speed ring in GT7, ask yourself, would you have the courage to keep your foot down in real life?